In this lesson, we'll be looking at separation techniques. In separation techniques, what are we separating in the first place? We recall from our previous class where we talked about element, compound, and mixture. We said that the component of mixtures, because they are not chemically combined, then we can separate them easily using physical method. So the physical method used in separating the component of mixture, those physical methods will be the focus of this lesson. So what are the methods used in separating the component of a mixture? The method adopted depends on the properties of the component. Recall also from our previous class that we said because when a mixture is formed by mixing two or more substances together, because the mixture, the component, do not react chemically. So the mixture formed retain the properties of the component. Because of that, we can adopt the properties of the component and use those properties to separate them from one another. So what I'm saying in essence is the method of separation used in separating the component of a mixture is based on the properties of the component of the mixture. As such, we have several types of separation techniques. And these several types of separation techniques, each method or each technique is based on the characteristic properties of the component to be separated. The table below itemizes different separation techniques and the characteristic properties upon which the technique is applied. We have the first method here, which is more or less like the traditional method of separation used at home. And that method is sieving. The sieving is used to separate component of mixture based on particle size. That is, you have a mixture of two or more components whereby the size of the particles of the component differ from one to another. Then you can adopt a method known as sieving to separate them. What do I mean? I have a mixture of a powdery substance, for example, like semovita. If you're in Nigeria, you know what I'm talking about, semovita. It's powder. Okay, let me use flour that is universally known. The components, you have a mixture of flour and rice. You have flour that you want to use in baking, and then by mistake, some rice pour into it. How would you separate the flour from the rice? The method known as sieving can be used to separate the flour from the rice. And that method is based on particle size. The particle of flour is far, far, far smaller than the particle, than the seed of rice. So you can apply sieving to separate that. And what is a sieve in the first place? A sieve is a special separating technique that uses the item name is a sieve, something like this, like a bowl. But under the bowl, you have a cloth that has mesh or holes, several mesh or meshes, if there's anything like that. Meshes. I'm going to show you the diagram of first now, something like this. And under this, you have a cloth here that has several holes, tiny, tiny holes, such that when we put a mixture of semo or mixture of flour into this and shake it, all the particles that are smaller than the mesh size will pass through the holes or through the mesh, while the particles that are bigger than the mesh size will remain inside the sieve. So, in essence, the separation technique known as sieving, the properties upon which the technique is applied is solid of different sizes. Because you have mixture of rice and flour, for example, both of them are solid. One has smaller size than the other. So anything that is smaller than the size of this mesh will pass through it inside the mesh or inside the sieve. That method of separation is called sieving. Something like, let me show you the ring. There's a sieve. Okay, look at it here. Sieve here. So this cloth here is a special cloth with holes. It is formed by intersection of holes, section of holes. So it can pass through it easily. While anything that is bigger will remain inside the sieve. The particle size is a property upon which sieving technique is used to separate mixture. The next one is magnetic separation. Magnetic and magnetic solid. A magnetic solid is a solid that can be attracted by a magnet. When a magnet is brought closer to some solid, there is force of attraction between the magnet and the material. And such magnetic solid are, of course, metals. So if, for example, I have maybe something like facial powder or any powder or any substance at all. Let me use facial powder as an example. This is my facial powder in a container. I love to rub powder, maybe for example. And then I have somebody that I feel like, okay, let me just boil this powder for this man. And then the person put pieces of iron filings into my powder. This is my powder. Then this tiny, tiny thing I'm drawing now are iron filings inside the powder. And I love this powder so much that I don't want to throw it away. What will I do to separate my powder from the iron filings? What I simply need to do is to look for a magnet and place it over the powder. Of course, all the iron filings within the powder will be attracted to the magnet, leaving the powder behind. So the property upon which this method of separation is based is magnetic solid from non-magnetic solid. Now, if you see those malam that go from house to house looking for metals to go and say, you see them dragging one magnet on the floor. Why are they dragging that magnet on the floor? They just want to pick pieces of metals from the floor. Because any metallic object that is on the floor that is in contact or close to that magnet will be always attracted to the magnet. So that is the method of separation they are using in operation there. There's picking magnetic substances from the floor, from non-magnetic substances. Then another method is sublimation. Sublimation is a special method of separation based on solid which sublimes from solid which do not sublime. Now, what does it mean to sublime? Sublimation has to do with a change of solid from solid state directly to gaseous state, change from solid state directly to gaseous state without passing through the liquid phase, without passing through the liquid phase. Now, that kind of change is called sublimation. The normal route for change of state is supposed to be from solid to liquid and then to gas, like water. But there are some solid that doesn't behave like this. When you heat them up, instead of going through the liquid phase first, they go directly from solid state to liquid to gaseous state rather, without passing through this state. Such phenomenon is known as sublimation. But there are few solids that behave like that. Example is iodine. So if, for example, I have a mixture of iodine with some other component that I want to get them separated, then I can heat up the mixture. The iodine will sublime. That is turning directly to gaseous state without passing through the liquid state. We're going to look at each of these methods one after the other. It's just like this table is just like a summary of all the separation technique we are going to discuss. Okay. So decantation is another one. Decantation is used to separate insoluble solid from liquid. Now, when we say insoluble solid, we mean solid that do not dissolve in a particular liquid. So if, for example, I have a mixture of gari that we drink, put gari inside water. You are not in Nigeria, you may not understand what I'm talking about. Gari is a special food in Nigeria that we soak in water before drinking it. Of course, it's a solid, it doesn't dissolve in water. The essence of soaking it is to make it soft before you drink it. So we normally do what we call decantation before drinking it because this gari has chaff. Now, when you put it in water, the chaff always floats to the surface and you allow it to settle a little and then bend the cup in a gentle way to remove those chaff from the surface. What you are doing is decantation. You can do that in the lab also as a method of separation. It's used to separate solid from a liquid, insoluble solid from a liquid. Insoluble is the key word here. That is solid that do not dissolve from a particular liquid. So you may have a cup like this, and in this cup, you have some solid with water inside. Of course, normally gently tilt the cup so that the liquid on top can then flow out, leaving the insoluble solid in the cup. That method of separation is decantation. We're going to look at it in detail. There's a technique or there's an approach in doing that, making use of glass rod and all of that, which we'll look at later. Then filtration. Filtration is used to separate insoluble solid from a liquid also, insoluble solid from a liquid, using a filter paper, a special paper called filter paper. We're going to look at that in detail also. They also have centrifugation, which is also separating insoluble solid from a liquid. Now, what this table is kind of doing is a kind of summary of all the method of separation. We are going to cover each of them one by one. And we're looking at the technique of separation and the properties upon which the method is adopted. Okay? So centrifugation, the method or the properties upon which the method is using insoluble solid from a liquid. For example, you want to separate the component of blood, human blood, or any type of blood, which is made up of plasma, which is a liquid component of the blood, and then the blood cells and platelet, all of them, which are the solid component. To separate the two, we make use of centrifugation. The blood cell has solid component, the plasma is liquid component. So centrifugation is based on what? Insoluble solid from a liquid. Then we also have evaporation, crystallization, fractional crystallization, and precipitation. All of these methods are based on soluble solid from a solution. Now, soluble, that is the solid dissolved in that solution. And so you want to remove that solid from that solution. Any of these methods can be used, either evaporation to dryness if the solid is not affected by heat. And if it is affected by heat, and you can adopt crystallization. And if it's a solid that is in a solution or liquid that is in a solution, that is in a way that the what do I call it? Ordinary crystallization cannot handle. Then use fractional crystallization. Then precipitation is also separating a soluble solid from a solution based on the fact that that solid is soluble in one liquid but insoluble in another liquid. Then let's assume I have this is A and then this is B. A is a solution of that solid, a soluble solid plus this solution A. Now, the soluble solid that I put in this solution A, if I put it in solution B, it becomes insoluble, doesn't dissolve in solution B. And so I will make use of that advantage by pouring solution B into solution A. The moment I pour solution B into solution A, the solid present in solution A turns to solid immediately by precipitating out. That is going to form particles that I can filter out of the solution. That method is called precipitation. We'll look at it in detail also. And you have distillation, which is used to separate solvent from its solution. That is, you have a liquid that is within a liquid. Then you want to separate one liquid from another liquid. That is miscible liquid, for example, ethanol and water. Ethanol and water, when you put the two together, they mix completely in a way that you can't tell the difference between the two. If you want to separate that kind of a mixture of two liquid, miscible liquid, what would you use? You can either use distillation or fractional distillation, depending on the boiling point. If the boiling points are far apart enough, then simple distillation is enough to separate one from the other. For example, the boiling point of ethanol is 78 degrees Celsius, while the boiling point of water is 100 degrees Celsius. These are far apart enough. So if you have a mixture of ethanol and water, and you want to remove ethanol from water, then distillation can do that effectively. We're going to look at that in detail by separating solvent from its solution. Now, where the boiling point are close together, then simple distillation won't do that. You use fractional distillation in that case. And the difference is that simple distillation, there's no fractionating column, while fractional distillation, there's a fractionating column. Again, we are going to look at that in details. Then using separating funnel. Separating funnel adopts the properties of immiscible liquid. Immiscible liquid, that is liquid that do not mix together. Good example is oil and water. Whenever you put oil into water, you see that the oil will always float on the surface of the water. This type of liquids are described as immiscible liquid. Immiscible means cannot mix. Things that cannot mix together. Immiscible liquid. To separate such liquid, mixture of such liquid from one another, we make use of a separating funnel, special type of funnel that has a control valve, something like this. Then here you have a control valve attached to it. And when you have the mixture of oil and water inside here, for example, usually the oil will be on top while the water will be below. So that when you open up this control valve, the water will flow out, leaving the oil. Of course, this glass is a glass funnel, so it's transparent. You can see a distinct layer of water and oil separated out, so that when you open this valve to let out water, you watch it closely, such that the moment all the water comes out, you just close the valve immediately, leaving the oil behind. We are going to look at that in details also. And the last one is chromatography, which separates solids from a solution. A solid is a solid that dissolves in a solution. Perfect example here is separation of component of ink. Ink as a substance or as a mixture is mixture of several colors. So if you want to separate the colors from each other, then we can make use of a separating technique called chromatography. So like I say, let's look at each of them in detail now.